Have you guys try some of these on your own? Okay. So the first page is pretty straightforward. You have a formula and you're plugging in all these numbers for n. N will represent the ranking of the sequence. So when n is 1, that's the first term. N is 2, the second term, and so forth. So for the first one, that's pretty easy, right? If you plug in 1, what are you going to get? Yeah, I'll get 2. Then what? 5, 10, 17, and 26, right? Pretty straightforward, right? Um, let's look at number 7. Do you guys know what the exclamation point does? Factorial, good. Or you can say n really loud. Dumb joke. I know, okay. 2n, or like in golf, 4. No, okay. So that'll be 2. And then if you do 2 times 2 factorial, what's 2 factorial? 2, so that'll be 4. If I do 2 times 3 factorial, what's 3 factorial? That'll be 12. If I do 2 times 4 factorial, what's 4 factorial? So it'll be 48. And if I do 2 times 5 factorial, what's 5 factorial? 120, so it'll be 240. Yeah, sorry, I should have not glossed over that. My apologies. So let's say you have n factorial. What you do is you take whatever n is, and you keep going down by 1 until you've got down to the number 1. And you go down, so like for example, 5 factorial would be 5, 4, 3, 2, 1. So you go down in increments of 1 until you get down to number 1. And yes, why is it useful? It's useful if you're looking for the number of arrangements. Say for example, okay, there's like 7 people here, right, in the front.
Yeah.
So like place, like say he's sitting in the first spot, he's in the last spot. How many boys can I arrange you guys? That'd be 7 factorial because I have 7 options that per seat. I could put Clay, Charlie, Marcus, Ollie, you, Andre, or East, right? Yeah. But then once I put someone there, there's 6 options for the second one. And 5 and 4 and 3. That's kind of like a probability kind of thing. It's a combinatorics.
Yeah.
So that's what it is. It's just you're multiplying all the numbers from whatever n is down to 1. Yeah, and that this is something that shows up often in BC calculus, this kind of notation. If we look at maybe one of the last ones here, let's look at 10, and then I'm gonna let you guys do the rest on your own. Unless you guys looks like some of you guys already got ahead of me. For this one, and by the way, the subscript here stands for the ranking of the term. So A1, A2, A3, A4, A5. So how will this look? If I plug in 1, I'm doing -1 raised to 1 minus 1, or -1 plus 100. What would that be? 499. Good. And by the way, what do you think that numerator is going to keep doing? Well, it's going to keep switching back and forth. So it's going to alternate between positive and negative. So if I do 2, what's -1 to the 1 power? And what's happening to the denominator? It's going down by 1 each time, right? So I should then get -1 out of 98. What's the next one? 1 out of what? What's the next one? What's the next one?
Is there a reason for the like lines of code?
I don't know, actually. Let's look at the answer key.
What? Like
Why the two lines? I don't know. Let me look at the answer key.
Because they want us to go to the 10th term.
oh, it's just like right.
Oh, it's actually 10. I did 5 terms. You know what? Just do 5 terms. Oh, showing the work. Showing the work.
And then it says, oh, then you get the 10th.
Then you get the 10th term. Okay. Actually, let's talk. What would the 10th term be for this one? What would you say at this point? What would the 10th term be?
-9.
Okay, good. So you've seen the pattern. Okay, let's do the factorial. That's kind of crazy. But that'd be 2 times 10 factorial. Don't do 10 factorial in your head, by the way. Use a calculator. But you can also find it under math and PRB. You can find it there. And the factorial button's there. Or if you hit alpha window, if you have the one of the newer calculators, it shows up, I think, option 9. I can't remember. Bless you. That one's pretty easy. If I plug in 10 for 1, you get 101, right? For a 10th term. So, okay. So that's pretty straightforward.
What is 10 factorial? Do you know? Not really.
Um, now this is the part, and I've actually been collaborating often with Ms. York because she has been telling me like, hey, here's what I really need from the BC pre-calc BC since when they matric at the AP Calculus BC. Here's what we really need. You guys really need to know how to recognize patterns, right? Now there's several patterns that we look at. Arithmetic patterns. Did you guys? No, you guys haven't done this in Algebra 2 trigonometry. An arithmetic series is when you're adding the same number over and over again. A geometric series is when you're multiplying by the same number over and over again. Those are pretty obvious patterns. We may see that here. We may not. I don't know. Actually, I don't think we do for these. But some of these patterns might be not random, but just not obvious, right? So take a look at 11. What pattern do you see for 11?
2 to the.
They're cubes. So I would say a sub n equals what? N cubed. And you're going to start with n equals 1. Because when n equals 1, what's 1 cubed?
1.
When you get n equals 2, what's 2 cubed?
8.
8. Good. Okay. Let's do one with a fraction. Ooh, let's look at 13. That's a good one. Okay, well, guys, how would you say, what do you say for 13?
1 over n over n.
Well, hold on a sec. What's the pattern for the numerator?
+3.
Plus 3. What's the pattern for the denominator?
+1 over 11. I guess +11.
Plus 11. Yes, good. So they march their own beat. So I would say this. I would say what's the right way to think about it? You can say what you can say 1 plus 3n. Yep. I'd agree. Because if you do 1 plus 3, that's 4. So here's how you can think of this. When it's what we call an arithmetic pattern.
It's not like an equation.
There is, yes, I'm going to say it right now. It looks like this. Arithmetic sequence looks like this. AN equals A1 plus n minus 1 times D. D is what?
Yep.
The common difference. So if your common difference is 3, so I'd imagine that the previous term would probably be, well, actually the first term is 4, duh. So if I work it out, what do I get? 1 plus 3n. So that's how you can make a formula for the numerator. Does the denominator follow the same pattern? Yeah. But what's the first term here? Sorry, close question.
What does D stand for?
Common difference.
Okay.
So what's the
In
first term?
numerator?
What's that? Sorry.
Is it the common difference in the numerator?
I'm doing both for both top and bottom separately.
Oh, I see it.
Yeah. What's the common difference for the bottom? And what's the first term? So if I work that out, if you think about it, it's just 11n, right? And that's a formula you would get for 13. If you can think of it intuitively, more power to you. But if you want some sort of predictability, if you're adding the same number over and over again, you can use that formula. That's totally fine. Some of these are not as obvious. I'll do one more. I'll let you guys have at it. Okay. We'll do 20. Okay. Kind of a funny one. So what do you guys think? What do you guys think we're doing here?
10 plus 10 to the n.
So
Times 10 plus n to the
it might help to do
plus
this.
10 to the n. Hold on. 10 to-
That kind of makes sense, right?
Yeah,
It's just 20n.
no, it's not. 10 times n times 10 to the n.
Oh, 2, yeah.
I think that was 1.
Yeah.
So if you're stuck, don't think about the formula right away. So this is using some intuition. Sequences are huge on that. So this will take some time to think through. That's why I said this is hard, not easy. But if you use a good strategy, so I was here's some good things, but let's kind of kill some layers here. Is that 10 plus 1, 1 10 plus 10? Why am I doing that? Because I see some sort of pattern, right? Okay. So I see some sort of pattern going on here. So we have 13,000 plus 1,000, 110 plus 10, 1,200 plus 100. So thoughts and formulas now. So I heard someone say 10 to the 0 power or 10 to the n minus 1. I heard someone say that. Would you agree that I could probably do something like that, right? That could potentially work. Okay. Okay. And then I could probably do this. Could probably do let me think here. I could probably do
10 to the n,
yeah, 10 to the n power. Mhm.
but you want to separate, like it'd be instead of 110 plus 10, be 100 plus 20. So you can multiply the 10 to the n minus 1 term by n.
So you say multiply
Multiply that by n,
this by n?
and then it instead of doing like 110 plus 10, it's more like 100 plus.
So hold on, can you repeat that again?
You do 10 to the n plus 10 to the n minus 1 times n.
Hold on, you just lost me. Okay, you totally lost me there.
I think Mr. Bradley.
Yeah.
You do one
Okay,
percent
well-
10 to the n and one part that is.
So you do 10 to the n, then okay, hold on. You do 10 to the n.
No, it's just 10 to the n minus 1.
For the first.
Excuse me. Yeah, go Ollie.
Here. Times n.
That's crazy, right?
Every term apart from the first step.
It is weird. I know. Audrey, you have an idea. Oh yeah. Well, hold on. Is it about the origin? Yeah. So the origin comes out from the part.
It's 10 to the n plus 10 to the n minus 1 plus 10.
It's one dimensional motion. When the position of the part is 0.
Yeah, that's the same.
Hold on. William, can you say it one more time? So 10 to the n, then what? Plus. Oh, I got you. Does that work? It works. That works. Yeah. Yeah, that does work. Yeah, it's a little crazy. Because you plug in 3.
Or you can factor it out.
Actually, I like what William said. So let's decompose it this way. Okay, that works. And they have 10,000 plus 4,000. Yeah, that works. Yeah, good job, William. Yeah, because you get 10 to the n power plus, and then the thing is that you're multiplying by a number times 10 to the n minus 1. Yeah, that works. That was a tricky one. Yeah, I'd agree with you. Yeah. Yeah, what do you got? Yeah, there might be another one that works. Yeah, tell me. Okay. Times 10 to the yeah, because you could actually factor it out. Yeah, that works. Yeah, because if you think about it, let's see what William had, right? Or actually, let's take what you had and what if I distribute it back in? You get back to the same thing William had. So they both work. But you found it by inspection, which is great. Yeah, because that would be 10 to the n power. Yep. You get the same exact thing. They would both be valid. Yes. Yeah. And by the way, there's a lot more to it than just this. This is more just getting you to think about patterns. That's what we're doing today. So why don't you guys keep working through this? I already put the answer up in school, G. You can check your answers, right? And if you have any questions about tasks, just call me over. I'll come and answer your questions. So, okay, yeah, I'll come by. How about that? But yeah, go ahead.
Um, yeah, I have like work up here. I feel like the work you needed to show.
Okay, so you
I
need,
understand I did it up here, but like.
so you need to show me the derivative, which you're not showing me.
Okay, fair.
Also, you need to show me what t equals when you said equals 0, which you didn't do as well.
So you think that this counts for zero work, and it's very clearly what you need to do.
Your inverse cos is 0. Okay, you didn't. Okay, I'll give you half point. I'll give you half point. Okay, I'll give you that. That's fine. Right. That's fair.
Nah,
So at least that puts you up to 80%.
this is like 100% right. Like, look, you can even see that I erased the thing. Like,
Okay.
I erased the thing.
Okay. I do like our explanation.
Yeah, you're also.
And then, wait, what?
Right, for three.
No, I'll come take a look because you're asking a question. He's not looking at yours also.
No, you're right.
Probably,
My bad.
it's probably wrong. You explained to your friends.
And so I just needed to do the product rule again here.
Oh, it's.
Well, actually, I remember you asked, you did a product.
Oh, yeah. That was.
No, that was number 9 or number 10. Yeah, because you didn't. That one, let's talk about that one. So here's what I would do. So I start off by saying 5 times bracket secant 2x minus pi.
Just a negative one.
So just prime it first, right? Before you do the derivative. Then that 3 moves to the front,
So for two.
which you did do.
Yeah.
Bottom word.
Keep this intact,
Negative
which you
one,
did do.
Two.
So far you're doing great.
Times two.
This is where the wheels fell off.
Two.
You didn't multiply the derivative of secant. You didn't do that. Because you have to now multiply by the derivative of secant, which is secant
Okay, then.
2x minus pi times
I thought
tan.
that was the outer function.
Negative one.
Nope, that's the inside of the brackets.
Negative
And
two.
then you gotta do another derivative 2.
And then you don't know that.
Okay,
So that's 3 gets it off.
well, so let me show you my rubric.
And then
Okay, so you got 1 point for that.
Just
Here's where I got a little, okay, yeah.
0, 1.
That's why I got confused. See, what you did was you didn't keep the inside intact, right? Because you immediately took, you didn't
I
choke.
changed.
Yeah, you didn't, so that was the problem.
But like, I did that here. I wrote secant 2x.
Okay, but the thing is that you're not, so what you're doing is that when you're doing the outside, you're not keeping the inside intact. That's off the point. Because you wrote secant. Right? And also, there's no such thing as.
I know. I understood that. That's why I wrote it down here.
And also, I'm not seeing, I did see the 2. So basically I gave you a point here, and a point there. But I'm not seeing,
I'm not.
You see how I still split it? Like, even though that's wrong, like I still.
but even in your final answer, though, here's the problem, that should be secant cubed. Right, and you're not, by the way, you're not squaring these individually. You have to write secant cubed, or you have to put a
I was under the
bracket.
impression that these were the same thing.
No, but
You can square it 2x minus pi.
No, because when you do it like this, you're actually squaring 2x minus 5. You're not squaring this p plus. So I'm seeing a few things. Yeah, you got the 30, which is good, but you have the exponents in the wrong place. That also costs another point. And also, you don't have the right exponents here. So that's why you lost 3 points.
Yeah, it is fine. Okay, so.
I just don't I'll give a point back. Yes. Yeah. I'll do it right now. Perfect. Yeah.
Did you get the parentheses? It's just incrementing into twos. This is, we're making this way.
So let me recalculate that.
So then it's just 9 plus 2 times n minus 1, right?